We know that a Bayesian network is basically a visualization of conditional independencies between variables. But when do two Bayesian networks capture the same set of independencies? Let's see if we write the joint probability distribution using the Bayes rule. We see that it can be factorized differently in the form of a common cause. And by using the Bayes rule again, we obtain the inverse directed path. All of these structures have the same independencies set and the same structure skeleton. So, these three structures are in the same independence equivalence or I equivalence class. So if one of these three appears in a Bayesian network, we can turn it into any of the other two while preserving the conditional independencies. The I equivalent class is accordingly represented by a particular directed acyclic graph or a PDAG. What about a V structure? The corresponding joint distribution may not be factorized in another way, so V structure is not equivalent to any other structure and makes its own equivalent class. When there is no link between the parents in the V structure, it is referred to as an immorality. The story is different when there is a covering edge between the parents. All 6 triangle structures have the same independence set, so they belong to the same I equivalence class. So, to obtain the I equivalence class of a Bayesian network, we find the immoralities and make the rest of the graph undirected. Finally, we check if a direction of an undirected link can cause a new immorality or a cycle. If so, we use the inverse direction as the direction of the edge. The resulting PDAG is the I equivalence class.